Today we're doing area of composite figures. Composite figures are just figures that have more than one shape inside them. Okay. Here you can see you have a rectangle. You also have a triangle. And you also have a half circle. Here. To find the area of this complete figure, you find the area of each one of these figures. There's not a formula that would tell you what this is. But instead there's three different formulas. A formula will tell you this, a formula will tell you this, the formula will tell you that. So you use those three formulas, you find the area of each smaller figure, shape that you can find, and you add them all up. Now this is a semicircle. So just like on the, and I warned you guys on the homework that we just graded, right? It was asking for the area of a semicircle. When you find the area of a circle, it's going to give you the whole circle. Do we need the whole circle? No, because this side of that circle overlaps with this. So we don't need it. So how do we find the area of this half circle? Take whatever we get and we divide it by 2, right? And that would tell you the half of that area. So let's do that. Write this down. Okay, and one thing I want to say when you're doing this, make sure you pay attention to the details, okay? And pay attention to what they're telling you, because you can easily get fooled, right, by a dimension they tell you. Now, I'm going to show you what I'm talking about here in a second. But let's first, we have to find this whole area. What are the two shapes I could break this into? Ben?
A rectangle and a triangle.
A rectangle and triangle, right? Now here you can see these dots, these dashed lines make it obvious, but they're not going to make it obvious. They're going to give you a rectangle with a trapezoid on top or a half circle on top, and sometimes it's not going to be obvious what the shapes are. So you have to look, how can I form these into shapes that I do know, which this one again is obvious, a rectangle and a triangle. Right? The formula for area of a rectangle is the same as the area of a parallelogram. What's the formula for area of a parallelogram? Base times height. Good, class. We just talked about it a few days ago, right? Base times height. So what I'm going to first do is find the area of this rectangle. So I take 15 times 23. 15 times 23 gives me an area of 345. So the area of this is 345. But is that my answer? No, I left off the triangle. So now we need to find the area of the triangle. What's the formula for area of a triangle? Camden?
Base times height.
Base times height.
Multiply.
It's not just base times height. There's something else. What we got to do to the base times height for area of a triangle? Kurt?
The area of the triangle is BH divided by 2.
We have to divide it by 2. Good. Okay, it's 1/2 the base times the height. Right? So we can take the base times height divided by 2. Now, here's what I talk about by looking at the details, paying attention to the details. Someone tell me, and you're going to get it wrong, but go ahead and just tell me, what is the base of this triangle here?
6 inches.
It is not 6 inches, but I know you think it's 6 inches. Right? And that's, I told you, you're going to get it wrong. I'm not making fun of you. Right? Because everybody sees this is pointing here, and they think this whole thing's 6 inches. But is there any way this whole thing from here to here is 6 inches when this is 15? No. So what is this 6 inches referring to?
That one little line.
This is little edge of the triangle that sticks out. Okay? So what would be the total length of this base?
27.
It's 27. How did you get 27?
I multiplied 6 by 2 because there are 2 of
Okay?
these edges.
There's 2 of these edges. So I've got 2 of them. So I'm going to do 6 plus 6. And then you add it to what?
The 15.
The 15. This is 15 because this is 15. So that's why you got to pay attention to the details here. So your base is not 6. It's not 15. It's 27. Okay? That's what I meant by paying attention to detail. Okay? And everybody always gets that wrong. They automatically think that's 6. But is there any way it could be 6? Right? Even if this isn't a scale, even in drawn right, is there any way this could be 6 if this whole thing's 15? That wouldn't make sense, would it? So pay attention to what they give you. Rarely are they going to give you exactly what you need. Every once in a while, they're gonna make you have to add this up. Here, obvious. This is 15. Got to be 15 here. But they're gonna make you have to do some work to find one of the numbers. So 27. My height is 8, and then I times it or I divide it by 2. All right. So 27 times 8 is 216. 216 divided by 2 is 108. So is that my answer, 108? I have to, here, that's the area of that triangle. So I have to add it to 345, the area of the rectangle with the parallelogram. 108 plus 345 gives me 453. And because it's area, it's a square unit, so it's inches squared. Alright, so here we're getting an area, kind of looks like a snow cone or ice cream cone. What two shapes can I make out of this, Ben?
A semicircle and a rectangle.
Okay, a semicircle and a
Triangle.
triangle, right? Okay, good. Definitely not a rectangle. A semicircle and a triangle. So I need to find the area of both. So I'm going to do the triangle first. So the formula for every triangle is base times height divided by 2. So I take 6 times 16, divide it by 2, which really is the same thing as taking 6 times 8, which is 48. All right, Sierra, tell me, how do I find the area of that semicircle? So before we can find the area of the semicircle, I need to find the area of the whole circle. So we use the formula area equals pi r squared. They're giving me 6 here, which is the diameter. So I need to find the radius. How do I find radius if I know diameter? So to find the radius, I divide the diameter by 2. I get 3 right there. Okay, so 3 squared times pi. Pi is 3.14. So 9 times 3.14 gives you 28.26. Now usually you would round here, but I don't want you to do that yet because we're not done with all our calculations. All right, because I've found this entire circle. Do I need to find the entire circle? Well, this part of this circle, this part is already here, wouldn't it? So do I need to find it again? No. So how would I find just this part?
Divided by 2.
Okay, because this is half that circle, I could divide it by 2, right? So I take 28.26 and divide it by 2. That's what I meant by I wasn't done with my calculations. I get 14.13, which I'm going to round the nearest tenth here. Right? And then I do what? How do I find this total area?
Add 48 with 14.
Okay, I add my 14.1 that I got for your circle with my area of the triangle, which is 48. Right? Which, what is 48 plus 14.1? 62.1. So I took my 14.1 plus my 48, and I get 62.1, and that's millimeters squared. Any questions? All right, so just to keep you from having to hunt down all these formulas, I put them all in one slide for you. Okay? These are the 4 shapes that you have to make everything you see into. Right? You have to divide them up into one of these 4 shapes. Right? Either a parallelogram, triangle, trapezoid, or circle, because these are the 4 formulas you know. Parallelograms base times height. Triangles base times height divided by 2. Trapezoid, the one that messed everybody up when we did it, You add the two bases. You don't multiply them. I had several students that multiply them. You add the two bases, times by your height, then divide by 2. Pay attention. Trapezoid and parallelogram are not the same thing. Too many people saw a trapezoid and they used the parallelogram formula. Okay? Parallelogram has opposite sides that are equal and parallel. Trapezoid has one pair of parallel sides. If both sides aren't parallel, you can't use parallelogram. You got to use trapezoid. Then you've got circle equals pi r squared. We worked with it yesterday. Make sure you're aware of what are they giving you. Are they giving you diameter for a circle or are they giving you radius? Right? That's really important. But everything you're going to see needs to be broken down into one of these 4 shapes. Right? And then you find the area of each of those shapes and then you add them up. Okay? Just like we've been doing. The last one was in 2 shapes. It was in a circle and a triangle. So we found the area of each of those. It was a semicircle, so I had to divide this by 2. But then I added those. The one before, okay, it was a parallelogram in the triangle. Right? The first figure you saw had a triangle, a parallelogram, and it had a circle. Right? But everything's going to break down into one of these 4. And then you add them up. Alright, here's the last type of problem we're going to do. Write this down. Okay, here is a shape they give you. They call this a ceiling. This is the shape of a ceiling. And they tell you a ceiling tile covers 3 square feet. How many tiles do you need to cover this ceiling? So what we do is we find up the total area, which we use by finding the area of the triangle and the area of this parallelogram. We add them up. And then it's just like the problem we did a few days ago that asked you how many bags of fertilizer was needed for a lady's yard. You found the area of the yard, like you would do here, find the area of ceiling, and then you divide it by the 1,000 square feet that each bag would cover. And it told you how many bags you need. So this is going to do the exact same thing. So first thing, I find the area of a triangle. The formula for area of a triangle is base times height divided by 2. So I take 5 times 12 divided by 2, which that's the same thing as taking 5 times 6, which is 30. Then I find the area of the parallelogram. Right, which is base times height or length times width, which is 12 times 10, which is 120. So what's my total square feet of this? 150. I add those up. I get 150 square feet. But is that my answer? All right, what I have to do is I have to divide it by the 3 square feet that each ceiling tile covers. 150 divided by 3 is what?
50.
So I need 50 tiles. And there's my answer. All right, here's your homework for today.